In this video, we're going to discuss projectile motion in which a ball is being shot off at an angle theta. In previous videos, we've discussed projectile motion, two-dimensional motion, in which a ball is being shot off horizontally off a cliff, so the angle is 0 degrees. It's not being shot off at an angle greater than 0 degrees. Well, this problem, we're going to shoot a cannonball, or you can be kicking a soccer ball at an angle theta. So we're going to start off by drawing our surface, and then we have this soccer ball, or it could be a cannonball. It's being kicked or it's being shot off at an initial velocity, some value, V0. V0 stands for initial velocity, and it's being shot off at an angle theta. So this ball is going to travel through the air, and it's going to land exactly where it took off from. So it's a flat surface. The ball lands right here. So whenever you get a problem like this, the first thing you should always do is you need to break down the you need to break down the initial velocity into its x and y components. Because the ball is doing two things. When it's being kicked at an angle theta, it's moving sideways, so it has a horizontal velocity, and it's moving up, so it has a vertical velocity. So let's find those values. Well, the first thing, break up your vector V0 into its x components, let's call it V0x, and into its y component, V0y. How do you do that? You're going to use your trig functions. You're going to simply say, if I remember correctly, cosine theta is equals to opposite. If this is theta, that's your opposite side over hypotenuse. Sine theta is equals to opposite over hypotenuse. So V0y is my opposite side. My hypotenuse is V0. So I bring the V0 over. So V0 sine theta gives me my V0y. Well, my initial velocity times sine the angle is being shot off at equals the initial vertical velocity. And you're going to use the same idea to find the horizontal velocity also. Except you're going to be using cosine theta. So cosine theta is adjacent over hypotenuse. Cosine the angle is adjacent over hypotenuse. The adjacent side is V0x, your hypotenuse is V0. So you're going to use your algebra skills to bring the V0 over. So V0 cosine theta is V0x. That's the first thing you should always do. You should always break down your vector into its x and y components. And that's what we've done. We've shown that this ball, or this cannonball, or this soccer ball, has a horizontal velocity, which is V0 cosine theta, and it has a vertical velocity, which is V0 sine theta. Now, as this ball travels through the air, it also is encountering gravity. So there is this acceleration of gravity, negative 10 meters per second squared, or negative 9.81 meters per second squared. As the ball travels up, we're going to say we're traveling through a vacuum. So there's no friction, there's no air resistance to impact the horizontal velocity. That means that the horizontal velocity stays constant. It's always present. It doesn't change. It doesn't diminish. It remains whatever value it is. However, as the ball goes up, the vertical velocity is going to change. Because even though we are in a vacuum, gravity is present at all times. So gravity is going to encounter the vertical velocity, and gravity is going to impact the vertical velocity. And as you go up, the gravitational acceleration is opposite, in the opposite direction as the vertical velocity. So that means the vertical velocity is going to diminish, slowly going to decrease. By how much? By 10 meters per second every second. So if the vertical velocity was 100 meters per second, then 1 second later, the vertical velocity will be 90 meters per second. And another second later, the vertical velocity will be 80 meters per second. And another second later, the vertical velocity will be 70 meters per second. It's diminishing by 10 meters per second every second until it disappears completely and it becomes 0. When the vertical velocity becomes 0, then the ball cannot go any higher. So that's considered the highest point. So the highest point is when the vertical velocity is 0. The horizontal velocity will still remain what it was to begin with. The horizontal velocity will still be V0 cosine theta. But the vertical velocity diminishes to 0. That's why it's the highest point. And then when the ball starts falling back down to the ground, the vertical velocity starts increasing. Because now the acceleration of gravity is pointing in the same direction as the ball as it travels downwards. So the vertical velocity will go from 0 to negative 10 meters per second. Negative only because it's downwards. Then 1 second later it's going to be negative 20 meters per second. Then the vertical velocity is going to become negative 30 meters per second. Then it's going to become negative 40 meters per second. And it's going to keep increasing by 10 meters per second every second. That's the vertical velocity. The horizontal velocity will stay the same throughout. The horizontal velocity won't change because we're in a vacuum, there's no air resistance, there's no friction, there are no forces, no accelerations that are impacting us on the x-axis. There's nothing impacting us on the horizontal axis. So our horizontal velocity will stay the same. I'll even put an extra diagram in here. Ball's right here. Its horizontal velocity is Vx, same as V naught cosine theta. The vertical velocity starts to diminish. So it's less than what it was originally. So you can draw the vertical velocity here, or you can draw the vertical velocity here. It doesn't make a difference. All I'm trying to show is that this vertical velocity at this point is less than this vertical velocity, because the ball is slowing down as it goes up. The ball will speed up as it comes down, but it's slowing down as it goes up, because gravity is always present, and gravity is always accelerating us downwards. Okay? Even at the highest point, gravity is accelerating us downwards. It's just changing the ball's direction. Over here, the vertical velocity becomes 0, and then finally, when the ball starts coming down, the x velocity is still present. It's still the same as what it was before, and the vertical velocity starts to increase. Now remember, because we're increasing, don't let the negative throw you off. The negative just means downwards. So you could have an increasing velocity that goes from 0 to negative, because that's what's happening. The vertical velocity is becoming negative, so it's increasing. The negative just means downwards. So the vertical velocity starts increasing because the acceleration of gravity is accelerating it, and then finally when the ball gets back to where it started off from, right here, we know that the horizontal velocity is exactly what it was to begin with, V naught cosine theta, and the vertical velocity will also be exactly what it was to begin with, because this point is identical to this point. So the vertical velocity over here is going to be negative V naught sine theta. The vertical velocity over here was V naught sine theta. It's the same because whatever gravity takes away from you, gravity gives it right back to you. However gravity slowed you down, it's going to speed you back up. Whatever energy gravity takes away from you, gravity is going to give it right back to you. So everything's going to be identical. If this point is identical to this one, then the x velocity is going to be the same, the y velocity is going to be the same, the resultant velocity is going to be the same. This result velocity is going to be the same as what it was to begin with. The angle theta is going to be the same. This angle theta is going to be the same as this angle theta. Okay? And you can draw the vertical velocity here, or you can draw it head to tail and draw it over here. And this triangle looks identical to this one, except it's this one, the ball is going up, and over here the ball is coming down. So there are a couple of things you're going to be asked to find. First thing you're going to be asked to find is how much time does the ball spend in the air. So when they say how much time the ball is spending in the air, they're saying compare this point to this point, because that's the ending point, that's the starting point. Find the time it takes to go from here to here. They're comparing those 2 points. Well, one of your equations is acceleration is final velocity minus initial velocity over time. You have to make a decision. Do you want to use variables on the x-axis or the y-axis? Well, you want to use variables, or you want to use the axis that gives you more information. The y-axis gives us a lot of information because we've got the acceleration of gravity, we've got the initial velocity, we've got the final velocity. The x-axis only gives us the horizontal velocity. It doesn't give us anything else. So I'm going to go with the x-axis. I'm going to take variables from, I'm going to go with variables from the y-axis because that gives us more information. So I'm going to take the final y velocity, the initial y velocity, the y's are reminding me, the subscript reminds me that I'm using the y-axis, and I'm going to solve for time. So time is going to equal, I'm going to bring time over to the left side of the equation, bring the acceleration to the right side of the equation, final velocity minus initial velocity over acceleration. What does that mean? Well, what's the final velocity? My final vertical velocity, and we're using vertical velocities, you want to stay away from the resultant velocity, and you want to stay away from mixing up variables from the x-axis with variables from the y-axis in one equation. So I'm just using the vertical axis. So the final vertical velocity is negative V naught sine theta. What's the initial vertical velocity? The initial vertical velocity is V naught sine theta. And what's my acceleration of gravity? My acceleration of gravity is negative 10 meters per second squared, or negative 9.81 meters per second squared. What does this simplify to? Negative V naught sine theta minus V naught sine theta is negative 2 V naught sine theta over negative g. Your negatives are going to cancel out. This negative is going to cancel out with this one, so the negatives disappear. That, ladies and gentlemen, is the time it takes for the ball to travel from this point to this point. Next, your teacher may ask you, give me the range. The range is the distance from the beginning to the end, the horizontal distance from the beginning to the end. So your teacher may say, from here, give me the horizontal displacement, dx, or they may call it x, or they may call it r for range. Whatever they call it, you can choose whatever letter you want. If they're saying, give me the displacement, the horizontal displacement, you need to know two things. You need to know how much time the ball spent in the air, and you need to know the ball's horizontal velocity, because the horizontal velocity dictates the ball's motion on the horizontal axis. So the horizontal velocity is v naught cosine theta. The time is 2 v naught sine theta over g. So if you need to find the range, you're going to go back to your equation. Average velocity is displacement over time. What are you using as your average velocity? Your average velocity is your x velocity, your horizontal velocity, because it's not changing. You can consider it an average velocity. What are you going to use for your displacement? Well, dx, x or r, whatever you want to choose, and your t is time. So if your teacher says find me the range, you simply have to multiply the horizontal velocity with the time. So horizontal velocity multiplied by the time will give you your range. What's your horizontal velocity? Your horizontal velocity is v naught cosine theta. What's your time? Your time is 2 v naught sine theta over g. That is going to give you your range, how far the ball travels sideways. Finally, the last thing your teacher may ask you is they may ask you, I'm going to highlight this, this is to get the range. The last thing your teacher may ask you, they may say, find me the height. Find me how high the ball went. Find me this distance, this height. So they may call it dy, they may call it h, whatever letter they want to use, they may call it just y. But they say, give me the height. How high did the ball go? So to find the height, you are being asked to compare the first point with this point. Okay, not this point with this point. Because to find the height, the ball starts up here and ends up here. So they're asking to compare these 2 points. So to find the height, you're going to be using y variables again, because you're being asked to find something on the y-axis. So that makes sense. You have to use variables that exist on the y-axis. So to find the height, you've got a couple of different choices. You can simply start off by saying that this ball has an initial velocity of v naught sine theta. Its final velocity is 0. And to find the height, you can say, I'm going to use my equation. Final velocity squared is equals to initial velocity squared plus 2ad. Final velocity is y, y, and this is a y, because these are all on the y-axis. Well, what's your final velocity? Your final vertical velocity over here is 0. So this value becomes 0. What's your initial vertical velocity? Your initial vertical velocity is v naught sine theta. And what's your acceleration? Your acceleration is negative g dy. So your acceleration of gravity is negative 10 meters per second squared. dy is what you're looking for, and you're going to use algebra to solve for dy. So you're going to bring over the v naught. Okay, so I brought the v naught sine theta squared, this whole quantity to the left side, so there's a negative there. 2 times negative g makes it negative 2g, and I have dy. So to solve for dy, I'm going to divide by negative 2g. That's how you're going to find the height. The negatives are going to cancel each other out, and that's good, because the height should come out to be positive, because the ball is going upwards. This should be a positive value. So v naught sine theta, this entire quantity squared, divided by 2 times 10, or 2 times 9.81 meters per second squared, will give you your dy. That's your height. That's how high the ball goes. So keep in mind, you're comparing different points in these problems. You're comparing this point to this point, and you have to make a decision. Do you want to use variables on the x-axis or the y-axis? Then you're comparing this point to this point, and you're using variables on the y-axis because you're finding a y variable. These are some of the equations that help explain projectile motion when a ball is being shot off at an angle of theta. Now the reason why I kept everything in the letter form is because you may be given some of these variables, so you can then plug them in and solve for the other unknowns and work backwards. whatever direction you want to use, feel free to do that. But that's one of the reasons why I left everything in variable